NASA's Voyager 1 spacecraft is the most distant human-made object in space, currently drifting over 14 billion miles away from Earth. It made history in 2012 when it crossed into interstellar space, becoming the first human object to do so. This crossing marked a major milestone in space exploration, pushing humanity beyond the limits of our solar system. This transition into interstellar space meant that Voyager 1 exited the heliosphere, the protective bubble formed by the Sun's solar wind. Once outside, the spacecraft entered a region filled with cosmic radiation and mysterious particles. The shift wasn't abrupt, but rather a gradual change tracked by increasing cosmic rays and changes in plasma density. Imagine launching a spacecraft over 45 years ago using technology far simpler than today's calculators, and it's still exploring the galaxy. This was all possible through a mission that was originally only supposed to study Jupiter and Saturn. However, Voyager 1 exceeded expectations, proving the incredible value of long-duration missions. One of the most astonishing facts about Voyager 1 is that it still communicates with Earth using a 23-watt transmitter that's weaker than a household refrigerator light. Even though its signals travel at the speed of light, they take over 21 hours to reach us. This communication delay shows how far Voyager 1 truly is. The spacecraft carries a unique golden record, which is like a time capsule from Earth. It contains greetings in 55 languages, sounds like thunder and heartbeats, and music from across the globe. There's even a brainwave recording of a person in love, meant to capture the depth of human emotion. Launched in 1977, just days after its twin, Voyager 2, the spacecraft embarked on what scientists call a grand tour of the outer planets. This tour was made possible by a rare planetary alignment that happens once every 176 years. By using gravity assists, or slingshot effects from planets like Jupiter and Saturn, Voyager 1 gained speed without extra fuel. Without this cosmic shortcut, the mission to Neptune alone would have taken over 30 years instead of the 12 years it did take. These gravity assists revolutionized space travel and allowed Voyager to gather incredible data about the gas giants and their mysterious moons. Voyager 1 recently made another breakthrough discovery by detecting a faint, constant hum from interstellar gas. This hum, picked up by its plasma wave instrument, suggests that even the vast emptiness of space is filled with low-level activity. Scientists say it's like hearing raindrops on a rooftop, but here, the raindrops are charged particles drifting through space. This detection is helping scientists map the interstellar medium, the substance that exists between stars. It's made of gas, dust, and particles from supernova explosions. According to NASA scientist Dr. Stella Coker, these faint signals give us a new way to measure the density of space far beyond the Sun's influence. What makes Voyager 1's achievements even more impressive is its resilient technology. The spacecraft operates on computers with only 69 kilobytes of memory, less than a millionth of the power of a modern smartphone, yet these systems have worked for decades in the harshest environment imaginable. Voyager 1 is powered by an RTG, a radioisotope thermoelectric generator, which converts heat from decaying plutonium into electricity. This power source is expected to last until 2025. After that, Voyager 1 will go silent, drifting endlessly in the Milky Way, carrying with it the legacy of exploration. The Voyager missions have already reshaped planetary science. For instance, they revealed volcanoes on Io, a moon of Jupiter, and ice geysers on Neptune's moon Triton. These discoveries showed that moons can be geologically active like planets. That was a game-changing revelation in planetary science. Voyager 2, still operational, remains the only probe to visit Uranus and Neptune. It revealed icy rings, tilted magnetic fields, and new data about their atmospheres. The missions also discovered lightning on Jupiter and the mysterious hexagonal storm on Saturn, changing our understanding of planetary weather. Crossing into interstellar space didn't happen all at once. Scientists noted changes in the amount of cosmic rays, plasma wave density, and magnetic fields. However, one surprise was that the direction of the magnetic field didn't change as much as expected, suggesting the Sun's influence reaches farther than previously thought. This observation has challenged existing models of where our solar system ends, pushing researchers to rethink their theories. Some scientists now believe the boundary between the heliosphere and interstellar space is more of a fuzzy transition rather than a sharp divide. Operating in such extreme conditions means that Voyager must be accurate planning essential. The 1970s-era software still runs the spacecraft, a feat of engineering. A single software glitch could end the mission, which makes the spacecraft's longevity all the more impressive. Scientists like Dr. Redstone, the mission's longtime project scientist, have praised its engineering marvel and said, "Voyager continues to inspire generations of scientists." More than just science, the Voyager missions symbolize humanity's curiosity and hope. The Golden Record not only carries greetings but also a star map pointing to Earth's location. Despite debates about contacting extraterrestrial civilizations, the missions are a reminder of our desire to reach out and connect. As Voyager 1 ventures farther, it encounters interstellar dust and charged particles from long-dead stars. These particles are like fingerprints from supernovae, helping astronomers study how galaxies evolve. Despite outdated instruments, Voyager captures priceless data, which scientists treasure. NASA estimates the cost of the Voyager program at about $865 million back then, around $4 billion today. Compared to modern missions, it was incredibly cost-effective. Yet the amount of scientific data returned is immeasurable, enriching our understanding of the universe. The mission showed that long-duration space exploration is feasible, inspiring projects like New Horizons, which visited Pluto. The importance of redundancy in systems was another lesson. Both Voyagers still have backup thrusters that function, proving the value of well-thought-out design. As Voyager 1 moves farther, the signal weakens. NASA engineers use advanced algorithms to sift through cosmic noise, ensuring the data isn't lost. The Deep Space Network's massive antennas are like giant ears, amplifying Voyager's whispers from across the galaxy. Voyager's longevity is partly thanks to its simplicity. Fewer moving parts mean less chance of failure. Its tape recorders, once cutting edge in the 70s, are now relics that still perform flawlessly. Modern engineers often cite Voyager as an example of durable design. Moving at 38,000 miles per hour, Voyager 1 would take about 73,000 years to reach the nearest star. Despite that, it continues to send engineering updates. Every transmission is a gift from the edge of our solar system, a message in a cosmic bottle. In late 2023, Voyager 1 experienced a 5-month communication blackout. Scientists found that a faulty memory chip was causing the issue. They ingeniously programmed the spacecraft to use a different part of its memory, restoring partial communication. Today, Voyager is slowly regaining its full data transmission abilities. Dr. Suzanne Dodd, Voyager's project manager at JPL, noted, "The spacecraft's resilience is a testament to the brilliance of its design team. Every time we fix something, we push the limits of what's possible in space engineering." Voyager's continued success is shaping future missions like the Interstellar Probe concept, which aims to explore beyond the heliosphere faster and with more advanced instruments. But such missions face significant challenges, especially in funding and technology. They remain decades away from realization. Until then, Voyager 1 is humanity's lone ambassador to the stars. It continues to collect and send back information about cosmic rays, magnetic fields, and interstellar gases. Each discovery adds to our understanding of space beyond the sun's reach. The spacecraft's journey shows how much can be achieved through vision, perseverance, and science. Voyager's success isn't just a NASA victory, it's a human accomplishment, a shining example of what our species can do when we work together.